Alright, so now we're going to work on the second example. Uh, Here we have a boss on top of a part, and our tool list calls out a 3/4 inch end mill. We're actually not going to use just that 3/4 inch. To save some time, we're going to use a 2-inch face mill to rough out all of this outside geometry. If we use just the 3/4 end mill, it will leave a gap here and leave scallops on these corners. There's lots of different ways around programming that, but we're going to be focusing on just using the circle block to see how that works. So we'll go ahead and get to that here. So we'll start out, we have the one that we just programmed. We'll go ahead and save as, and we're going to save it as example 2. Alright, so now go into our stock geometry. So we got a part set up, we go to more and stock geometry. So now we can change our length to 3.75 and 4 inches. Our thickness is still 1 inch. Alright, so now we'll get our tools set up. So we'll go to our tool setup. We have this tool 60 in here from last time. We can just change that to the 3/4 inch end mill. We'll just leave the speeds and feeds in here for now. It doesn't really matter. We're just working on the geometry for right now. Speeds and feeds we'll get into later. So for right now, we have the 3/4 inch end mill that we wanted. Now we'll go ahead and program a 2-inch face mill that's going to finish the bottom of the outside flange of this part. It's going to finish this section right here, and it's going to leave some extra stock on this main diameter here. So we'll do that, and then we'll come back in with the 3/4 inch end mill. They'll have a square corner, clean up these edges here. The 2-inch face mill we'll be using has a 60 thou radius. Most face mills that can cut this type of geometry are inserted, and they will have a round on them. And so if we want a square boss here, we'll want to use something with a square corner. Alright, so we'll go ahead and program our tool. We'll call the face mill tool 85, and we'll program it as a face mill. So now we'll call our diameter here 2 inches, but there's a couple different ways around leaving stock on the outside of our part. If our face mill is actually 2 inches or a little bigger, it will actually cut this dimension here, the 3.38. It'll cut it undersized, and our 3/4 inch end mill won't touch it at all. So we need to make sure, if we want to leave some stock on this boss here, we want to call this diameter a little bigger to leave some stock. So we'll add 20 thou, and that'll give us a 10 thou on each wall extra gap that our other end mill will clean up. On the later versions of this software, there's a parameter we can define to leave stock on the geometry. I'm not 100% sure what version the students are using right now, so we'll do it this way for now. We'll get into that stock allowance mode if the software has it, but for right now we'll just call this diameter big, and that will leave the stock that we want. So we'll define our speed here, call it 4,000, turn our coolant on, and our feed will go about 50 inches. Alright, so now we have that done, we can get to our programming. So we go to our part programming. So our center of our part is 1.88 and 2 inches. We can't assume that they mean 1.875, but that is most likely what they mean. But we'll just program it to 1.88. Oftentimes engineers will have the CAD drawing set up to auto round, but for right now we'll just program to whatever they call out. And our diameter here is 3.38. Again, that's probably 3.375. but we'll just assume whatever they called out is the correct dimension. Remember to leave this Z start position here at a positive value, usually 50 to 100 thou, to give some room for your rapid. Now our Z bottom is 0.25. Make sure on the Z bottom that you don't forget to put the negative sign. Oftentimes people will enter in the value but not make it a negative, and you'll have issues drawing and running your program if that happens. So for now, we'll go ahead and do our tool 85. This is left over from last time, so we'll change this. We're going to do it outside. Our start angle, we'll just leave it at 0 for now. And our pec depth, if we're using a face mill of this type, we could probably take 0.15 in one pass, but we'll go a little bit smaller just in case. This version of the software that I'm using has the allowances mode. That's this tab over here. I have it turned off for this program. You can go to your program parameters to modify that. But for right now, we'll just ignore that, and we'll use this 2-inch with 20 thou allowance on our diameter, 2.02, and that will get around to leaving extra stock. So now that we have this, we can go ahead and draw it and see what we get. Alright, so I made a common mistake here. You can see how the diameter is big. Well, when they called out the radius here, I forgot to divide by 2. Easiest way to do that is just to select the whole value and hit 2 divided by enter. And now we should have the proper value, so when we draw it, it'll look good. We can see our little blend over here. You want to keep in mind that this blend is the amount that cutter is going to move off and then blend into our actual tool path. This step over here is smaller than the extra stock you have over here. The tool will actually plunge into the material. Depending on the type of cutter you have, that may ruin your cutter or burn up your material. Some cutters just can't handle that, and even if your cutter can handle it, a lot of times it'll leave a divot where the Z motion stops. It'll vibrate just slightly, and it'll leave a little ring on the surface of your part. So if you're trying to hold a really nice surface finish, you almost never want to plunge directly onto your face. And we can change that in the program parameters, and we can go into our milling, and we have this milling 1, and we have a blend offset. So you want this value to basically be bigger than the value we have over here. So we could figure that up. I'll go ahead and just assume that 0.5 will be enough. We have this blend overlap. Basically, that's the gap between these two blends. If we zoom in here, it's basically from this point to this point. So if we wanted it to be bigger, we can make it bigger. But for right now, it's not that big of a deal. We can redraw it, and we can see that our blend now has this value from these 2 points is greater than this distance. So we should be plunging out here off of the material. Alright, so now we'll go ahead and clean up our boss here. So if we go to isometric, you can see the surface here. Now if we go back to our part programming, we could add a finish pass, but we'll actually just copy this block. It'd be a little bit easier. So we'll go ahead and go to the program review button, and we'll copy this block and paste it. So now we're on block 2. So this is a copy of our first block. And we'll go ahead and change our tool we're using. And we can leave pretty much everything else the same, except now we'll get rid of this peck depth, because we no longer need that. We've already removed all the material, and we're just doing a skim cut. So this peck depth here, we can leave at 0. Now we draw it. You can see our big end mill cutting it out. Our little tiny end mill comes in and cleans it up. And anytime you use a different tool, it'll change the color of the stock it's creating. So you can see these little orange spots and yellow spots. It's basically just two different tools cutting the same geometry. It thinks that the 2-inch and 20 thou face mill is 2 inches and 20 thou. So it'll draw it exactly how it thinks it's going to cut it. But we added that 20 thou to leave stock. So in reality, when we run this program, there'll be the 20 thou extra on this part. So the 3/4 inch end mill will take that off. And so now we have a finished part. So we'll go ahead and save this out. So we go to the Program Manager, and we'll go to Save. And that's it for this part.